Hi, I'm George Woodbury from College of the Sequoias in Visalia, California, and in this video we'll go over how to solve absolute value equations. There are two types that we're going to learn in this video. The first is where you have where you can rewrite it as an absolute value of an algebraic expression equal to a number, like the first two that are on the screen. And then we'll move on to talk about what happens when we have an absolute value of an algebraic expression equal to the absolute value of another algebraic expression. Let's start with problem 1. The absolute value of x minus 3 equals 5. So I'm going to make a sidetrack into a simpler problem first. Suppose instead we had the absolute value of x is equal to 5. What we're trying to find is a number whose absolute value equals 5. And there's two of those that we know. We know that the absolute value of 5 is 5, but we also know that the absolute value of negative 5 is equal to 5 as well. So that tells me that x is either equal to 5 or negative 5. And that's the way that we're going to solve these. We'll take the expression, as long as the absolute value is equal to a positive number, we'll take the expression and set it equal to the number and its opposite, and we'll solve those two equations. So if we have absolute value of x minus 3 equals 5, that will split into x minus 3 equals 5, or x minus 3 equals negative 5. We've changed that from one absolute value equation into two linear equations that we know how to solve. The first one we can solve by adding 3 to both sides to get to x equals 8. The other one we can add 3 to both sides as well to get to x equals negative 2. So there are two solutions here, negative 2 and 8. What's different about problem 2 than problem 1? We've got absolute value of 2x minus 5 minus 3 is equal to 18. What's different is the absolute value isn't isolated yet. That has to happen first, and that can be done by adding 3 to both sides to isolate that absolute value equation, that absolute value expression on one side by itself. So we've got absolute value of 2x minus 5 is now equal to 21. Now we can split this into two equations. 2x minus 5 equals 21, or 2x minus 5 equals negative 21. Both of these we're going to start by adding 5 to both sides, and then we'll finish by dividing both sides by 2. So the first one, when we add 5, we get 2x equals 26, and when we divide by 2, we get x equals 13. For the other equation, when we add 5, we get 2x equals negative 16. And when we divide both sides by 2, we get x equals negative 8. So the solution set, we have negative 8 and 13. Okay. So isolate the absolute value, set it equal to the number and its opposite, as long as that number was positive. We'll handle what happens when it's 0 or negative in a later video, and then solve each of the resulting equations. Problem 3, we're going to use the same idea to solve this, although we don't have the absolute value of 2x plus 9 equal to some number. We have the absolute value of 2x plus 9 equal to the absolute value of x minus 3. One thing we know, if the absolute value of a is equal to the absolute value of b, one of two things must be true. Either a and b are exactly the same, or a is equal to the opposite of b. And so what we're going to do is we're going to take the expression inside the first absolute value, 2x plus 9, and set it equal to what's in the second absolute value, x minus 3. And that's one of our equations. And for the other, we'll take 2x plus 9 and set it equal to the opposite of x minus 3. For the first equation, it's already simplified, so we want to collect all the variable terms on the left by subtracting x. X plus 9 equals negative 3. Subtract 9 from both sides, and we get x equals negative 12 as one of our solutions. For the other one, we've got to distribute that negative sign through the parentheses. To take its opposite, it's like multiplying it by negative 1. So distribute the negative 1 through the parentheses, and we have 2x plus 9 equals negative x plus 3. To get all the variables to the left, this time we have to add x to both sides. 3x plus 9 equals 3. Subtract 9, and we get 3x equals negative 6. Divide both sides by 3, and we get x equals negative 2. So our two solutions are negative 12 and negative 2. A quick check of these. Let's start with a negative 12. 2 times negative 12 plus 9, that is negative 24 plus 9, or negative 15. Negative 12, negative 12 minus 3, that's also negative 15. And the absolute value of negative 15 on each side equals positive 15. So that checks. Let's try it again with x equals negative 2. 2 times negative 2 plus 9, that's negative 4 plus 9, or 5. On the other side, we've got negative 2 minus 3, or negative 5. But the absolute value of 5 is equal to the absolute value of negative 5. They're both equal to positive 5. So both solutions check, and this method is valid. All right, let's try one more real quickly. This is set up to go. So we have 4x plus 3 equals 2x minus 7, or 4x plus 3 equals the opposite of 2x minus 7. First, on the left, the first equation, subtract 2x from both sides. 2x plus 3 equals negative 7. Subtract 3 to isolate the variable term. 2x equals negative 10. Divide by 2. We get x equals negative 5. For the other equation, distribute through that negative sign, and we have 4x plus 3 equals negative 2x plus 7. Add 2x to both sides to collect the variable terms on the left, giving us 6x plus 3 equals 7. Subtract 3 from both sides to isolate the variable term. 6x equals 4. Divide through by 6 to solve for x. By the way, 6 doesn't go into 4 evenly, but we know that we can simplify that fraction by dividing out a common factor of 2. X equals 2/3. So our solution set, negative 5, 2/3. All right, that's it for absolute value equations. We'll move on to some absolute value inequalities in the next video.